Welcome back, ladies and gentlemen, to Oxygen Not Included. Now, if you have not heard about it already, there has been another upgrade preview that is now available for those of us that want to try things out before it's officially released. Yes, it has some bugs in it, but what is it? It is the automation upgrade preview available. Well, it doesn't... I read the whole title. Okay. What it is a couple of things. One, there is refined materials. That is, refined materials, it's a little bit different than actually heating up materials to make them something different. This isn't a furnace. We're talking about another tier of stuff that we can actually build within the game using, instead of ore, we can refine it. The other thing, and the most maddening thing about this, which is going to, some people are going to absolutely love and other people might hate a little bit, is logic gates here. They say that you can potentially build your own supercomputer using logic gates. So there's a lot of different stuff over here. Let's take a look at it just to get you guys going on some of this stuff. And over here, as we can see, I've got something set up, a little bit of demonstration. I've been working on this all evening, trying to figure out what works, what doesn't work, where the bugs are, and all of that fun stuff, so that we can kind of learn some things and, you know, get it ready for release so that things work properly, you know, when everything runs awesome and we actually understand what half this stuff does. Okay, so let's start off here with automation. So this is the equal button on your keyboard or the very last tab here. And what we have here is automation wires. We have bridges and gates, several gates, signal switches. We also have the Atmos sensor, hydro sensor, and thermal sensor, which have all kind of changed a little bit in functionality. So when you trip on over to yes or no, or on or off, what it was previously, just run through the power wire, this will now send a signal, so you'll need to plug in your automation wire to enable or disable those buildings, rather than just enabling or disabling the power grid. So it's a little bit different there, and I think that allows us to have a lot more flexibility with the systems, and also kind of allows us to plug things in and control them a lot better without overpowering things. So far, I really like it. The clock sensor allows you to set up a signal that's going to start at a certain time and then end at a certain time. So if we actually click this down, what we can see here is the time of day. So we can kind of set this up and we can see how this works. If I just do an automation little wire from this, we can see that it is currently on because it's in the middle of the day. If I kind of go past that certain amount of time, then boom, it's off. So we know that this is 600 seconds, 10 minutes. So 10% is 1 minute within the cycle. You can kind of figure that out. It would be, this percentage here is a little bit weird because we can't hover over this and see a percentage. That's one of the things that I think we should look at. The pressure switch, pressure plate over here, pressure switch is not even a thing. The pressure plate allows you to turn a signal on if there's something on top of it and control how much that is, right? So if there's something on top of here, 10 kilograms or more, or, you know, whatever we want to actually type in there per the kilograms, we can, you know, flick a switch on. So for example, where that might be useful is when we're running a refinement for the polymer press right here. When we drop something off, maybe we want to turn that thing off, not to oversaturate your, you know, whatever your cooling solution is that you're trying to use for that polymer press. You know, or an algae kicks out some stuff and you want to come by and pick it up, but you don't want everything to continue running. I don't know. There's some things that allow that to turn on and off. I have an example here that I'll kind of take you guys through that runs through a good amount of this stuff, but not all of it. Then there is also a duplicate checkpoint, and this will wait while the light is red. So if we take a look at this system here, this light is green, so duplicates can go past it in this direction if it's green. However, if it is red, you know, there's going to be a little stop gate and they won't be able to go past it. So it's kind of like a door, a one-way door, one way or the other. Works a lot like the exosuits do. So continuing to focus on the automation side of things, what we can see here is a lot of these power plants. For example, the manual generator, the hydrogen generator, natural gas generator, petroleum generator, everything but the coal generator will have a plug-in for automation, meaning that you can signal it on or off depending on however you're going to control that. There is also some new conductive wire that will allow you to move up to 2 kilowatts worth of power, which is much more useful for navigating that around your base. It does scale in, negative to core as compared to just the standard wire, so that's -5 as compared to the conductive wire, meaning that is -25. However, this conductive stuff down here requires refined metals, which you'll need to use a metal refinery in order to get. So this turns the ore into chunks of refined metal. That's essentially what it does. There's also a new mini liquid pump, so it just runs less volume through the pipes. It also consumes quite a bit less power as well, down at 60 watts. And there's also a liquid shut off for the liquid pipes. And what that is the same sort of thing as a liquid valve, except for that liquid shutoff allows you to turn that valve completely off with the use of the automation system. So you can send a signal to that says, turn this off, and it should cut the flow. That same stuff exists within the gas system. So you have a mini gas pump, and you also have a gas shutoff valve, so that allows you to turn that off. These do not allow you to adjust the flow. As you can see, there's no flow option. They're basically just an on or off valve that's run by automation. Nothing over here in the utilities allows you to turn it on or off based on the automation signals. However, there is one option that you can do, and that is use a power shutoff. So this is a clamper that will actually just cut the power to that part of the loop dependent on a signal. So that's how you can control, that sort of equipment. Also down here is a thermal shift plate. So what that does is it allows you to move the thermal energy from an area to another area, kind of in the background, so you can build it over some tiles a little bit and kind of plug them together. There's a lot of really interesting materials down here, one of them being diamond. Check that out. So if we just take a look at this is temporary art. Boom. Check that out. That's cool, right? So what this should allow you to do is kind of basically create a radiator. You can use the mass, you can use the conductivity there to kind of move energy from one side to the other. Now, as far as transferring across a tile, right here I have some abyssalite, and inside of here we have wire bridges. Now, normally we'd use wire bridges to do this sort of thing, and the answer is that these thermal shift plates don't actually work across something like the abyssalite tile right here. So we will see that the temperature here should go through these wire bridges and start to change this temperature when I unpause it eventually. Here we go. So now this is getting hotter on the left, colder on the right, as things try to even out. And that's what we would expect from the wire bridges. Now, if I get rid of these, I just clear this out and go back to the thermal shift plates, just using wolframite, which was the same material I used in that example there, and repainting the temperature so that everything's right. There we go. At 500K over here. It's real hot, but whatever. What we can see here is that the temperature is not dropping on the right and transferring over here to the left and vice versa. So there's the example. Thermal shift plates don't work across the tiles, even though they look like they could potentially do that. Or at least to abyssalite tiles, like it's probably trying to go through that tile and just isn't able to. However, let's say we were to replace that with one of these new tiles that we have available to us. We have plastic tiles that we got in the last update, but now we have metal tiles. So these metal tiles have other properties that are increase their, the benefits, right? Plus 50% run speed, tungsten, steel, gold. You can make golden floors. Let's see what a gold tile does right here. Look at that. Boom. So what I'm seeing here is that the thermal energy that's moving through this gold tile, which has thermal conductivity of 60 right here, is also hitting these shift plates and spreading them out very quickly. So there is definitely reason for the shift plates. And we saw how quickly that was able to, even out right there. So that was quite fast, and it was a lot faster than what we saw with the wire bridge. So there's definitely something to these, even if they don't transfer directly through the walls, kind of like we are able to do with some other equipment. Boom, really useful. I love these things. Now there are two new pieces of equipment within the refinement tab here. One we already talked about, which is the metal refinery. The other is the rock granulator. I just made an experiment video on how to make more sand. Well, guess what? Now you can just crunch stuff up inside of here and make more and more sand. So by looking at this, we can turn 100 kilograms of copper ore, well, back into copper and into sand as well. So that's another way to get some refined metals there. So if we look at copper, it's a refined metal. See that? So that's a very useful piece of equipment. Same with iron ore, right? So 100 kilograms in, you get refined iron and then sand. Now, if we were to use the metal refinery, 100 kilograms of core copper would copper ore would turn into copper refined. Wow, I messed that up, but you get the idea, right? 1-to-1, and then this is kind of 50% goes to sand. So with that in mind, there still is a little bit of use for the magma furnace, which is turning fertilizer, cooking it back into sand, because you can do that without loss if you use that storage compactor and have it, you know, contain dirt and sand. It'll all stay within there, so you can get a 1-to-1 ratio that way. And also, there is no fertilizer down there. Okay, so it doesn't completely get rid of that video. Ha, still useful. Nothing changed inside of furniture. We got a new skin for the exosuit forge. Alright, so this little example I have in front of you is just one idea of how we can use the automation system here to manage the power and how we're actually charging up this battery and all of that stuff. So what we have here is a metal refinery. Now this consumes 1.2 kilowatts. That's a lot of power. And if you actually add up this, that's the exact equivalent of these manual generators. So the only way that this metal refinery would ever run is if these manual generators were constantly all being operated. Otherwise, the power would drain out of it and you'd never be able to get the batteries charged up enough to actually get this thing to operate. You would just have to be using all of these at the exact same time in order to get it to work. So what we need to do is have a system that builds up the power and kind of stores it in some batteries and then dumps it into the metal refinery. Now I have these all hooked up to doors, and doors can be opened and closed based on their automation signal. So the mechanized airlocks can open up or close based on, you know, a yes or no signal, and the same with the pneumatic doors. You can also do that as well. So if we take a look at the automation loops here, I have pressure switches, pressure plates here, and if you're on any of these pressure plates, that will send a signal to a NOT gate. So this NOT gate right here takes in a signal, so it becomes active if the system that is connected to it is standby. So red is standby, green is active. So if this was red on the left, then this would be green on the right. So everything over here on the right is running through one of those clappers that I was talking about, and that is a power shutoff. So since this is red, it's open. If it were green, it'd be closed, and then the circuit would be dumping power outside of it. Each one of these doors in their open state, when they're active and they're plugged into the wire, will consume 120 watts. So right here, I have, 11 doors, and then I have another thing over here, which is a space heater, just to kind of give my duplicants something to do. Yes, I'm horrible. They have a space heater, and then they have a bunch of hydro fans next to it, just so that they don't end up idling, because you know these duplicants, they idle right here, right where it doesn't work. So they run over here and they do this thing. What I'm trying to say, though, is that this system is set up to consume 1.2 kilowatts, the exact same amount that I would be running through this metal refinery. So it's simulating that metal refinery running in a continuous operation. All right, so I'm going to let this run here, and what you can see is that all three duplicants here have jumped onto this manual generator. Now, the power that they're running here is running on over to these batteries, and they're building up this charge. So the cycle has ended here. And what we can see is that the automation loop here has gone to standby, therefore turning this to, green, or shall we say, active. So that closed the circuit over here, allowing you to power the sucker up. Now, I'm not sure they open or close circuits. I'm not an electrician. But what we got here is, boom, this stuff is on. So now we're drawing all of that power out of those batteries right now. So this system will go until it's drained out. So this entire system has now drained, and it's now available for these duplicates to come back in and start charging it up. Now the duplicant here, so Nicola here, if Nicola runs on top of this manual generator, then that enables these next two other generators to be visited. So, not Harold and Lindsay jumped on these other generators right here and started operating. So now they're charging the system here at 1.2 kilowatts. So you can see how the system works. You just build up the batteries, everybody runs away, and then it draws that power down. And even though one duplicate here left, the system isn't drawing out, to the point where it's just going to start going on and off and on and off, because it's running through this NOT loop right there, so the NOT gate. Here we go again. These batteries will hit max. These duplicates will take off, and we'll begin the next cycle. Now, the other thing that's important here is that I don't want these duplicates constantly coming back to these batteries if they still have charge inside of them. So what we can see here is the duplicate checkpoint. Now, this is important. This duplicate checkpoint, again, like I said, if it's active or inactive, it's going to have the arrow or not arrow. So if the duplicate checkpoint here has a standby signal running to it, it will block them off. Now, this requires power in order to have the standby command be active. So if this power is cut to this duplicate checkpoint, like if I were to just deconstruct this wire here, it will go back to green, right? So it's going back to active. So what this allows us to do is when these batteries run out of juice, this turns back to green, allowing them back to these generators. So they will never be able to come to these generators if there's power left in the battery. So you can see how this duplicate checkpoint is, at 0 here. So they're not, boom. Now that we've run out of power, Nicola can come back over here and start running on that generator. Now the other two generators are available for duplicates to start running over here. So with that in mind, you could replace this with maybe a hydrogen generator or a natural gas generator. So one of these is the primary, and then the other one turns on and off based on what the power needs are. Another scenario that we might run into quite often is having a system that turns on and off more generators based on the total power level of our batteries. So in this setup here, I have 6 batteries, 1, 2, 3, 4, 5, 6, and then I have a piece of equipment down here that's consuming 240 watts constantly, right? And we want to keep this up and running. Maybe it's running an air pump that we're using to power something absolutely critical, but the rest of this stuff is going to turn on and off based on when we're actually going to use it. However, we want these generators to come on once this power system hits 50%. So what I've done here is take these batteries right here, and these will drain hopefully before these, allowing this checkpoint to turn on and off based on its level. So the power grid looks like this. We have all of our generators running up to these batteries and then running down to these batteries here to this equipment that's going to be on, and then we also have the automation switch system turning on and off the rest of the equipment here. So I can see I'm building up charge, and I'm building it up in these batteries over here to the right, but I'm not building any power into these batteries over here on the left. So once these hit 40 kilojoules worth of energy, then at that point we should start to charge these batteries up here. Oh, come on, Nicola. You don't need to run this. No! What are you doing, man? Don't tell me. Oh, you sucker. Alright, so that's worked. See, we've hit maximum power over here, and now we're, pumping power into these batteries. For some odd reason, I can't get 3 duplicates over here. No! Stop! Get back on the hamster wheel. There you go. Everybody. Alright, so there we go. We've now hit maximum power across all of these batteries. It's currently using 240 watts, but once we leave, the power is going to spike up, and we're really going to start to draw a lot more off of it. Alright, so there we go. The duplicates have left. This duplicate checkpoint has turned off, and now we're drawing power out of these batteries over here. So once that hits 0, we'll see this duplicate checkpoint go back to green, allowing them to come back in and charge things up. So, not Harold down here is just waiting for the green light. And there he goes. And now that he's on this generator, these ones are able to charge up, so my other duplicates should come over here. If Nicola and Lindsay, I tell you what, you're really making this example hard for me. But there you go. I mean, that is an idea, at least one idea, of what we can do here with the automation system and using these gates and all of that fun stuff. At any rate, that's all I have for you guys tonight. A little bit of an overview of the upgrade, preview, and at least one crazy thing that you can do with it, which is battery management right there. And I tell you what, this has got me absolutely thinking. Biffa knows like what's on my mind, and that's what it was. I took a shower, I thought of all these crazy things that we could make out of this. It's ridiculous. I'm looking forward to it. We're gonna go turn into absolute mad scientists here and have a lot of fun with this automation upgrade. Looking forward to what you guys are going to come up with, share with, and just make crazy things. Let me know what you thought about this episode down there. If you liked it, let me know. I don't know. I'm messing up my outro, but if I've earned your subscription, then thank you so much for that. Have a great day, guys. Stay awesome. Peace. Brothgar out.